This is Professor Joe, your education advocate. Our topic is how we understand inductive versus deductive reasoning. Inductive reasoning investigates the process of drawing probable or fallible conclusions from premises. This kind of reasoning involves generalizing based on behavior observed in specific cases. Because the conclusion is derived from the specific cases, this allows the conclusions to be wrong even if the premises they are based on are correct. An example is there is smoke, therefore there is a fire. We know that smoke does not guarantee the existence of fire, right? Probably there is fire. However, to infer that there is fire based on smoke is reasonable, but it is nevertheless fallible. The reasoning is simply that as it is possible for there to be smoke without a fire, we may be wrong in asserting that there is a fire. In inductive logic, each piece of evidence in the data supplies the credibility of the conclusion, but remains probable. Deductive reasoning argues that the truth from premises necessitates the truth in the conclusion. This reasoning uses given information, premises, or accepted general rules to reach a proven conclusion. The following should be noted. Suppose that you have an argument and that the truth of the premises guarantees the truth of the conclusion. Then it follows logically that the truth of the premises makes likely the truth of the conclusion. Deductive reasoning, also called deductive logic, is the process of reasoning from one or more general statements regarding what is known to reach a logically certain conclusion. Inductive reasoning, also called induction or bottom-up logic, constructs or evaluates general propositions that are derived from specific examples. Deductive reasoning applies general rules to make conclusions about specific cases. Inductive reasoning observes patterns in specific cases to infer conclusions about general rules. For example, all men are mortal. John is a man. Therefore, John is mortal. This is an example of valid deductive reasoning. On the other hand, here's an example of inductive reasoning. Most men are right-handed. John is a man. Therefore, John must be right-handed. The strength of this inductive argument depends upon the percentage of left-handed people in the population. In any case, the conclusion may be invalid because inductive reasoning does not guarantee the validity of the conclusions. Some takeaways on this topic. First, a good scientific law is highly generalized and may be applied in many situations to explain other phenomena. Deductive reasoning can be used to deduce many experiments and prove a general rule. An example is the law of gravitation, that anything you throw upward goes down. This is valid and can be applied to all cases. However, the condition must be that we are in the sphere of gravity, inside the sphere of the earth. Second, inductive thinking is useful in constructing a hypothesis by showing individual cases to prove generalizability. Any conclusion is made from predictions and probability, assuming individual case is true. Third, many reasoners nowadays depend primarily upon information that is readily available, and they tend to rely on information that is easily accessible to them. This can introduce bias in inductive reasoning and draw conclusions based on such bias. Lastly, the demand for confirmation must be applied because clarifying and evaluating limited data and resources is important, avoiding the tendency to confirm without verification. In the past, for several centuries, people believed that the sun and planets orbit the earth, but it turned out that was not the case. Let us use both deductive and inductive methods to find a reasonable conclusion. In any realm of inquiry, let us determine what is true and possible. Thank you for watching. Please continue to follow my training videos.